I'm on PowerPoint, Chapter 18, slide number 9, question number 1. What's the pH of a solution that results from adding 25 mils of 0.1 molar hydrochloric acid to 25 mils of 0.15 molar ammonia? The pKa for ammonium is given. Well, there's a lot going on here. Let's see. I'm going to add HCl to a solution of ammonia. Well, this is an acid, this is a base. This acid will donate a proton to ammonia. That's going to form ammonium and chloride. Looks like we're going to have a buffer, unless all of this reacts. Let's find out. Let's see here. So let's see, I've got 0.1 moles of hydrochloric acid per liter. That comes from this information here. It looks like I'm using 25 mils of it. So what's that come out to? That's going to be 0.0025 moles of HCl. All right, how much ammonia do I have? Well, I have 0.15 moles of ammonia per liter. That comes from here. And it looks like I'm using 25 mils of it, which is 0.025 liters. What's that come out to? That one I'm going to need a calculator for. Let's just see it here real quick. 0.15 times 0.025, that's 0.00375. That's my moles of ammonia. This is moles HCl. Got 375. So it looks like I have an excess of ammonia. So this will react with this. And it looks like 0.0025 moles of the ammonia will react. So let's take our 0.00375, subtract 0.0025. All of the HCl will go away. We'll have 0.00125 moles of the ammonia left, because that much will react. And since this much of the ammonia reacted, we'll have 0.0025 moles of ammonium that has been produced. Let's make sure you understand that. There's a lot there. So, I started with this much ammonia and 0.0025 moles of hydrochloric acid. The hydrochloric acid reacted with the ammonia. 0.0025 moles, all of this reacted, producing 0.0025 moles of ammonium I should say, and 0.0025 moles of chloride, which we're not going to have to worry about. That's just a spectator ion. I need to subtract 0.0025 moles of hydrochloric acid from ammonia, because that's how much of this reacted. So this minus this gives me the amount of ammonia that's present. So you'll see I have a buffer present. I have a conjugate base and a conjugate acid. So I'm going to use a buffer equation now, because I'm trying to find the pH. So let's see, the pH, that's going to be the pKa for ammonium, which is 9.26, plus the log of the conjugate base. That's going to be 0.00125. It should be its concentration. So let's just divide that by a total of 25 and 25. So that's 0.05 liters. So that's the concentration of ammonia. And we'll divide that by the concentration of ammonium, which will be 0.0025 divided by also 0.05. What's nice about the buffer is the volume's always equal. I mean, they're both always in the same container. So ultimately, you really don't need to worry about the volume. All right? So it's the log of this whole thing here. So I'm going to take 0.00125, and I'm going to divide that by 0.0025. And now I'm going to take the log, what's 0.5? So I'm going to take the log of 0.5, log of 0.5, negative 0.301, and then I'm going to add that to 9.26. So my pH should be 8.96. I'm just going to stop here for a second and make sure this makes sense. So let's see, if I have equal amounts of both of these, then my pH will be 9.26 because I'll have the log of 1, and the log of 1 is 0. If I have more of the acid form, then my pH will actually end up being below 9.26, and that's indeed what I see. I have a little more of the acid than I do the base. If it turns out that your conjugate base is a little bit more than your conjugate acid, then your pH will be a little bit above the pKa.